if you really know what period of history of your underlying system has influence on your current state, that much data is required.
Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. How AI Happens is back in action. Hello, podcast land. How are you today? I'm so glad you are all tuning in for another classic installment of what I hope is your favorite AI, ML podcast. I have another wonderful guest for you. He's had a ton of experience in our space. Currently, he serves as the data science and statistical expertise leader for the Nutrition and Packaging Center over at Unilever, a company I'm sure you all know well. Dr. Satyajit Wattamwar. Satya, welcome to the podcast. How are you today?
Yeah, thanks, Rob. I appreciate this introduction. Yes, I'm doing fine. Yeah, looking forward to this podcast.
Me too, because Unilever kind of makes everything. Everything from like nutritional supplements to pens. I'm sure anyone listening to this could just sort of like reach around their desk or their space and probably find something that Unilever makes. And it doesn't just happen by accident. There is all of this amazing insight and data that goes behind this product development, which you directly oversee. And that's why I was excited to speak to you. So we'll get into that. I don't want to get ahead of ourselves here. Let's maybe get to know you a little bit and then we'll earn the insight. Yeah, I would love it if you wouldn't mind sharing some of your background, maybe some of your PhD work if you feel so inclined, and then how you kind of explain your current role.
Okay, yeah, sounds good. So my background is chemical engineering. And then usually up to the master's degree, you still are exposed to this physics-based modeling approaches, or the first principle modeling that we call. But then I got an inclination to learn a little bit more of the modeling. And one of the good field, traditional field I would call, is systems theory. Systems and control theory falls most of the time in the electrical engineering department. And they look everything from the system point of view. So for example, I was trying to do this data-driven modeling for glass manufacturing process. It's a chemical plant, or some of them were really modeling the functioning of the heart. Some of them were doing it for the electricity grid network. So you can imagine we all had different application. And at the same time, we were trying to contribute the core science or the algorithmic development as well. So to be specific now, my focus was bridging the gap between the world of the first principle or physics-based modeling and the data-driven modeling. So I developed many algorithms there that kind of marries these two worlds, best of the both worlds. I had a startup as well for 2 years after my PhD, and then later moved into the commercial role with General Electric. And then for 7 years, I was in the consulting field, leading various data-driven modeling approaches, because that also coincided with the early wave of data science when the IT world was also coming to this AI or the data science world, because there was some level of maturity in the back-end operation. And IT world was excited to see two opportunities at that time. One was the cloud and the power of AI. So basically, was a game changer for IT, and they upscaled their game from one level to another one. So before that time, you would hardly see any data scientist in those IT consulting companies. But now most of the major IT consulting companies have data scientists. So that's how I ended up into the world of data science.
Yeah. Thanks for giving us the background. And, I get to meet lots of physicists on this podcast, which is not something I expected, but it happens a lot. And I'm curious why you think there is this really common background for data folks, AI and ML folks, that is physics. Is it because math is math and the compensation is better? Is it because if you're a physicist, you get sufficiently good at math, but also the scientific method and conducting research, which is so important also at the early stages of some of this work? What is your take on that?
Physics tries to marry these two worlds, the basic science and mathematics, that foundation of mathematics, and apply it to some physically relevant problem. That's one of the basic thing in there is the physicist. But then second important thing is also, and that also had happened over the last 20-25 years, and that is towards solving this physics problem with the help of modeling and simulation approaches and the development of the algorithms. So they were very close already to this world of data science. And then the third thing is many of these physicists, they work with very large volume of data. So it is not enough for them to just know physics and mathematics, but also to have a very good know-how of algorithmic science. And many of them, in fact, go towards the hardware, learning hardware, because then the best comes by understanding of the hardware as well as the algorithmic approaches. Yeah. So take any example of understanding skies or the climate prediction or the CERN or Kern or however you pronounce it, the big particle collider. Yeah. It generates terabytes and terabytes of data. Yeah. And it's all physicists there. So they're close, and then slowly some of them also moved and use those learning into other areas like financial science and others. So I can imagine, yeah, you are right. Physicists have a very good affinity for this field, and they are almost there already in that field. So it is just a natural, gradual extension. Probably also it started paying well. So I can imagine they entered into this non-physics related domains but then they still enjoy this same set of use of algorithms to solve the problem.
You mentioned there that physicists in particular have this experience with huge amounts of data. And that strikes me as is probably the case at Unilever. You have decades of data collection across a pretty impressive breadth of products. Is that for you like a kid in a candy shop because there's so much data? At what point does it become overwhelming?
Very good question. Yeah, having a large volume of data which is less related with each other is a different thing than large volume of data for one problem. Okay, for example, again, the same physics example, two particles colliding, it generates terabytes of data. It is one problem. Yeah, you want to understand versus Unilever, where each product may have a limited data. Again, its operation has limited data. When it's being produced, it has a limited data. There is a link between them. There is influence. But then if you look at together, then it appears again a very big data. However, I can unlock tens of values from my data at Unilever, yeah, because I can formulate tens of different use cases, and each of them can be also small, but still unlock some nice value. Versus the big one that these two particles colliding, yeah. So there, the number of use cases will be fewer compared to ours, yeah. So big data is not the same in every case. It is about the context and then the industry and the value unlock it supports in that every industry. And therefore, at Unilever, we leverage this large volume of data, but there are tens and hundreds of use cases where significant value can be unlocked even with the smaller data.
That is really fascinating just because it confirms this burgeoning theory that I have, which is that people seem to be doing more with less, that it's not just about more data, bigger data, an endless arms race for who has the most. It's, what can you do with it? And maybe you don't need that much to have something interesting happen. Is there a critical, this is, I guess, it's sort of nebulous, but is there like a critical amount like, okay, nothing below this amount of data is meaningful?
That's really about the problem. Yeah. So I can explain. I will give an example of a product manufacturing in, let's say, a pilot plant or factories. Yeah. You can imagine we have a cloud where all our hundreds of factories data is there. And now I want to predict quality of our product that is in specific factory. I have a choice. I can look at all the data that is in our data lake in the cloud of across all the factories. But I know already, yeah, the operation in one factory is not influencing my operation in another factory. Yeah. So therefore, even many times there are multiple lines in the same factory. Yeah. And this physical understanding of underlying setup help us to know what data that we should be looking at, yeah, rather than doing a brute force data crunching. That, and most of the time, you will not believe that more data is not always leading into good quality model. Almost, I will disagree unless it is for the same use case. Yeah, simply like this example, the other factory is not influencing my factory where I want to model it. So that data is totally useless for me. If I use that data to model my product quality, in fact, I will have poorer models simply because my models will be an average between these two factory data. Yeah. So what is relevant data? What is the context of that data is more important. And then if I'm really modeling that, again, the quality, I will go back to my chemical principles now. Yeah. What is the time constant of my process? Time constant is again something defined in the chemical terms. Yeah. So that tells how much data you would need, because then you will capture all the relevant dynamics of your process. But that's about the operation. Now coming back into the formulation area where you mix up something in the laboratory, and then you are measuring something. So the time constant will be different there. So how much data will be required? It is on the time constant. But then that is making use of the understanding of chemical principle. Another domain, it will be different. So I would usually say the history of the data that really has influence is required. Beyond that is not required. Unfortunately, in other fields, this idea of residence time or time constant is not very effectively used. But you can imagine also in the financial world, when the Fed or all the government, the financial bodies, they change the interest rate. You can imagine how much time does it take towards influencing that. And then that amount of data will be useful. And to adjust those interest rate to influence the economy, they will not look at the data from last 50 years because that's not the use case. They want to influence the economy now. And that has been the dynamics that had happened over last 3 months, 6 months. I don't know. I'm not an expert in the financial system, but the idea applies. So if you really know what period of history of your underlying system has influence on your current state, that much data is required. And then second question would come, how fast you should be sampling and things like that. But that's the second part.
That is a great answer. And it's not the one I expected, but it makes perfect sense in terms of, okay, we must work in the context of the problem that we're experiencing. And this notion of making a time constraint, you say it's not utilized in lots of areas. Is that merely due to a lack of expertise? Why do you think that's the case?
Yeah, I would say this world of data science has been evolving. It's very relatively new in the sense it's marrying these various ideas which I explained earlier. So therefore, many times the experts in one field are not fully aware or they don't leverage the things from their end. So it may sound a bad example, but let's say computer science. Idea there is as much data that we have, the better models I will get. But then the physical understanding usually is not embedded into the understanding of the problem. And then the idea goes, more data, the better it is. But that's not correct. So I think there is nice opportunity, and this will evolve because you will see many electrical engineer, chemical engineer, mechanical engineer, they all are entering into the world of data science. So they are marrying these two things, the understanding from the classical field and leveraging the power of algorithms in the world of data science. So again, I will give another example. In the computer science world, there are now especially this deep learning and other, some optimization algorithm like a reinforcement learning, extremely popular. But if you really go back into the world of mathematics, you will see there are hundreds of algorithms, not just belong to this class, but many other class. And they all leverage the system point of view of modeling, which is classical system point of view modeling. So more and more these things are happening. And in fact, things are exploding lately. And it is becoming, to be honest, a bit difficult even for the scientists to kind of get their heads around of all these new developments.
Right. Okay. Yeah, that makes sense. Now, Satya, when I began this show, I did not anticipate how many data science folks I'd be speaking to, which perhaps is a comment that portrays vast ignorance on my part. The reason I did, of course, is because it's hard to get technical about AI without at some point speaking about the data and the data operations underneath it or alongside it. And so I was hoping you could kind of explain what is your connection to some of the AI subject matter experts and how you partner with those teams to layer in AI over at Unilever.
As a company, naturally, we have a very strong pool of data scientists. But then I can say we are more closer to the problem. We understand the algorithms and things like that. But then we are still more leveraging the traditional data science approaches. So, for example, there are now this deep learning or the Gen AI approaches. So they are relatively new. Of course, we have a few scientists there. But then we see where we have gaps. And then we connect with the outside world. And in the outside world, we have very strong network of partners, especially many companies who have strength in various areas. So we build an ecosystem of partners. Many of them have strength in the traditional approaches. Many of them have strength in the consulting. Some of them have a nice strength in the world of computer science. Some of them have very nice strength in the world of Gen AI and the others. So we try to bring in this awareness and learning inside, and not just with respect to the know-how, but also the products. Yeah. So many times these new developments leads into new product innovation, and depending on their maturity, we also bring them. So I think we are connected, and then wherever there are gaps, then we try to fill those gaps. But the world is evolving so fast, I must admit. And yeah, so a big job. Although the AI is helping us to improve our efficiency of day-to-day operation, and that we are benefiting from that, but because there is so many developments ongoing, that keeps us busy just to stay up to date or up to the state of art in the world of AI.
This is, what is the word? Not puzzling. This is what is so challenging, I suppose, about just the AI question, is that folks in your position, and many, I think, are, on one hand, you are utilizing AI to make your own job better. And on the other hand, you are building it for the company. Like there's a sandwich approach of like you are getting it from both sides. So I would love to know just, well, maybe we'll start with one hand and then go to the other. In what ways are you leveraging it to make your job easier?
Usually, I bucket usability of AI into two major groups, or two major value unlocks, or two major buckets, whatever you call. One is operational efficiency improvement. Yeah. And the second one is really goes bit uncommon, is innovation. So only those companies, either any big company or small company who is in the business of R&D or the innovation, they are leveraging the second bucket. Yeah. The first bucket is more on the operational efficiency, is what most of the buzz of Gen AI is around. Yeah. And then naturally, the first one is kind of a stronghold of IT software company and consulting companies. Yeah. Like, for example, all the co-pilots from Microsoft or other companies. Yeah. Or large language models. So all of them supports efficiency increase. And then we have been using them a lot. Yeah. And that's also over last 2 years only. Yeah. Like, I don't imagine a day when I don't use the co-pilots. Yeah. And it's not just about meeting, summarizing and things like that, but as part of this learning and solving various problems, I have also many questions. Yeah. And then one of the first advisor for me are these co-pilots. Yeah. So of course we all know they may not be fully foolproof, but that gives me an idea. Even my data science question, when I need to formulate something, yeah, maybe a set of requirements, I have to collect my thoughts. Yeah. And that takes time. But then the starting point can be Copilot as well. Yeah. So it is, I call it operational efficiency again as a result of this Gen AI tools. And now the innovation. Yeah. So the innovation is, as I said earlier, is really specific to those who are in that business. Yeah. You can imagine a car manufacturing, yeah, coming up with a more aerodynamic shape to have less fuel consumption, or maybe the batteries. Yeah. How to expand the battery life. Yeah. All these are innovations, and there are niche Gen AI approaches and niche Gen AI models. Yeah. And they are playing a big role there. So we as a company, we are leveraging both. And for me as a personally, I use the first one to take care of my own daily work. But the second one is my core business, which I leverage and help my company Unilever to develop a new product, superior product, and better products.
It's such a reasonable way to split things up, innovation versus efficiency, just because right now I feel like we are in the stage of the hype cycle where the people who would be responsible for investing, continuing to invest, are really pushing for ROI, for pushing for like, okay, is this actually working? Is this helping us? Is it saving us money, or is it making us money? Is it saving us time? And so to put it in terms of time saved, as an example of Copilot, is something that makes it easier for a CFO, for example, to sign off on. And then you have this, like the innovation, the more research side. This is a little squishy. You have to be thinking in a little more long-term of a fashion, I suppose. And the appetite for that is always big in the beginning, and it just slowly wanes over time, unfortunately. I think we've seen that over the last several years.
Indeed. But then there is one nice selling point now also for the innovation, and that is, let's say, new product development. Yeah. If you compare traditional approach, yeah, let's say somebody wants to make a better shampoo, there is a big scientist team which has to be at the cutting edge of the research. They have to follow the conferences, journal papers, and they need to be up to date with the research. And then the experimental scientist then goes to the production and other areas. Now in the innovation, the Gen AI models, the scientific models that can allow you to extract relevant information from thousands of literature, and also to experiment, the in silico experiment with millions of combinations, and the same also applies in silico experimentation for what happens in the factory. So that now all life cycle has reduced significantly, and at the same time you have scanned far bigger spectrum. So therefore there is now even the innovation, in my opinion, is getting more support. So innovation, so Gen AI exploration activity in the innovation space is also getting nice support. But I think it is going slowly in terms of the larger companies like Unilever or major other companies who have significant R&D presence and a significant investment in R&D. They are leveraging it more. But I think that will be the norm. And for the same reason, with all the companies that we are working in this innovation space using this Gen AI or AI approaches, to be honest, they are doing very, very good.
Yeah, that is very well put. And, Satya, I don't think we're going to find a better bookend than that to this episode, because we are, of course, here creeping up on optimal podcast length. But before I let you go, though, I did want to ask you to share some wit and wisdom here at the end for the folks out there in podcast land. For people who are seeing someone in a role like yours at a company as large and impactful as Unilever, what advice would you give them so they can forge their career in such a way?
Oh, yeah. There are actually many things. So it depends on what you are interested in. That I strongly put. So if somebody is really looking for, let's say, growing in the career ladder, then it's not justifying one's own interest. So in fact, I recently read there is current age is not only about climbing the ladder, but climbing the knowledge ladder, not the hierarchical ladder in the organization. That's very important, because it's very clear. Many mundane jobs will be taken care by the AI and the later robotics. Even the white collar or the service industry job, what will be valued is your knowledge, experience, as well as the wisdom. And even more important, your ability to connect collaboratively with others as a team. So even I see very senior leader in our organization who are senior than me. They spend so much effort to understand the technology. They are not coming even closer to my background. They are coming far too different background, but the amount of effort they put to understand this technology is tremendous. So those who are aspiring to make a career, depending on their stage of the career, there are various important things that they need to consider. Of course, those who are at early stages, they need to learn about the skills, and then get hold of the various understanding of the algorithm, the implementation, and various knowledge from various domains. So I see a future where both are required, unfortunately, where you need to have a certain vertical specific knowledge and understanding of that specific business. Even like in the FMCG or CPG, we would be operating different than our counterpart. Our databases are different. Our operation is different. Although at somebody who is looking from outside, they are making same thing. But unless one has know-how of one's own specific business, the applicability of the technology is less there. So therefore, one needs to be also with patience, understand the business that you are engaging, and have this other leg in the technology field, to unlock some of the value there. And slowly, in my opinion, then only one can grow in one's career. Unfortunately, I would see that going into another vertical will become more difficult, simply because this know-how of a specific business operation will be even more critical going forward. Because you are supposed to create new value, and that is possible only after understanding the underlying opportunities or the problem in your organization. But then one has to keep both the activities in parallel. Understand the business, try to get hold of the data in your organization, at the same time continue learning the technology.
It is great advice. The only thing I would disagree with is that it's unfortunate. I think it's exciting, and it's a chance to use your whole brain. And this is how it is. This is constant adaptation and development. So the advice to upskill constantly and to understand the business is well taken and well given. Satya, this has been great having you on. I wish we could keep going, but I guess that just means I'll have to have you on for part 2. So Dr. Satyajit Wattamwar, thank you for being here. I've really loved chatting with you today.
Yeah, thanks a lot, Rob. I really enjoyed this podcast. And I wish all the listeners a very nice time afterwards. Thanks.
How AI Happens is brought to you by Sama. Sama's agile data labeling and model evaluation solutions help enterprise companies maximize the return on investment for generative AI, LLM, and computer vision models across retail, finance, automotive, and many other industries. For more information, head to sama.com.